So, you decide to give a ball a good kick across the floor. It goes flying. But here's the cool part. For those few seconds it's soaring through the air, you're not just witnessing the usual three dimension of height, width, and depth. But there's another dimension in play. Time. Now, I know what you're thinking. How on earth can we see time? Well, we can't exactly see time itself, but we can observe its effects. And what better way to do that than by watching the ball's movements? As it travels through space, we get a glimpse of that progression of time. It's like a sneak peek into the fourth dimension. But when we dive into discussions about space-time, we often throw in an extra dimension, the fifth one. Think of it as a micro-dimension, not as obvious as the other four. You won't spot it just by kicking a ball around. In the epic movie Interstellar, there's this whole thing about these fifth dimension beings secretly helping out the main characters. These beings are from another realm or something, and they hook them up with a sweet spaceship and a super convenient wormhole for intergalactic travel. At the end of the film, they go through a black hole and end up in this crazy library of infinite knowledge. And those mysterious beings are actually McConaughey himself. Before we get too deep, let's start with the building blocks of everything in this universe. Point. Yep, that tiny little dot holds the key to it all. Let's label it as zero dimension. Dimension number 1 is just a line, a super skinny line stretching from point A to point B, like a tightrope walker defying gravity. It's like a ghostly concept that we can understand, but in reality, our world is all about things we can touch and see. Even the tiniest stuff around us has some length and width, unlike this elusive line. Dimension number 2 is a plane. When you take a line and give it some width, you got yourself a plane. It's like a flat surface that you can view head-on. Think floors, ceilings, tabletops, TV screens, and movie screens. As easy as it is to imagine a plane, it just can't quite exist in our reality. Yep, even sheets of paper have some depth to them. However, you've seen the second dimension if you've ever watched any pre-internet cartoon. Typically, all the vintage cartoons out there are two-dimensional. Now, welcome dimension number 3, which is space. It's the one we call our own. When you add a little something to a line, it magically transforms into a plane. And guess what? When you blow it up from a different angle, that plane becomes an object in our super cool world. We're all about length, width, and depth here. They're totally our jam. Time is dimension number 4. Close your eyes and imagine yourself right now, in this very moment. Now picture yourself 2 minutes ago. Or how about 2 days ago? Wait, let's take it up a notch. 2 years ago. And what about 2 centuries ago? Now here's where things get funky. Imagine all these versions of yourself from different points in time, connected along a timeline. It's like you're physically linked to each of these variations of yourself. It may sound complicated, but in reality, the jump from the third dimension to the fourth dimension is just like the previous jumps we've made. Imagine you're looking at a line. If you change your perspective a bit, that line becomes a whole plane. It's like a revelation that the super skinny line you saw before was just one part of a bigger physical object, its length to be exact. Now let's take it a step further. When you shift your gaze from the plane to an everyday object or even a person, that plane becomes like a frozen snapshot of that thing. It's just one side of it, without any depth or perspective. But if you physically turn around and look at that single face, you're entering Dimension 3. If you repeat this process once again, you'll find yourself in Dimension 4. Now you're not just looking at an object from its 3 special dimensions, but you're seeing it as one face of a timeline. It's like realizing that any object we know is just one part of a whole timeline. If you could step outside of time and zip across that timeline, you'd witness all the different versions of that object, its past, present, and future. Like flipping through a crazy flipbook. It's like having all those individual frames strung together forever in both directions. And what about dimension number 5? This is where we find McConaughey in that bookcase scene. Get ready to leave the 4th dimension behind and dive into a world of endless possibilities. You see, those physical manifestations we witness are just one side of the story. They represent the realm of possibility. Now imagine a timeline as a bunch of possibilities stemming from a single moment. Let's use your birth as an example. Each moment in your life is like a face on a never-ending you from the fourth dimension's perspective. Now picture this timeline as just one face on a crazy object made up of countless other timelines. Each line represents all the different moments and faces that could have happened after your birth. It's like the fifth dimension's view of you. Back in 1905, Albert Einstein dropped some pretty cool knowledge on us with his special theory of relativity. He revealed that space and time are all tied together by the speed limit of light. So technically, our universe has 4 dimensions of space-time. But for our everyday lives, we like to keep things simple and think of the universe as having 3 dimensions of space. You know, north, south, east, west, up, down, and 1 dimension of time, which is past and future. Easy peasy. In the 1920s, a couple of genius physicists named Oscar Klein and Theodore Kaluza were like, hey, what if there's a 5th dimension of space? They got this wild idea from Einstein's theory of relativity, which showed that mass can warp space-time. So they wondered, could this extra dimension explain another force called the electromagnetic force? Turns out, it totally could. But here's the catch. The electromagnetic force is way stronger than gravity, like 1,040 times stronger. So for this extra dimension to work its magic, it had to be super tiny. We're talking smaller than an atom, like microscopic small, so small that we wouldn't even notice it. Picture a particle, like an electron, zipping through space and doing loop-de-loops around this 5th dimension, like a little hamster on a wheel. Kaluza and Klein's 5-dimensional theory got hit hard when 2 more fundamental forces were discovered in the atomic nucleus: the strong and weak nuclear forces. But many other scientists who believe in string theory brought back the idea of extra dimensions explaining forces, and it's been about half a century since then. According to this theory, the universe's fundamental building blocks are not particles, but these super tiny strings made of mass energy. These strings do their thing by vibrating in a 10-dimensional space-time, with 6 of those dimensions rolled up way smaller than an atom. String theory suggests that our universe might be like a 3-dimensional island, or a brain just floating around in this massive 10-dimensional space-time. This could explain why gravity is so ridiculously weak compared to the other 3 fundamental forces. The idea is that while the forces are stuck on the brain, gravity sneaks out into those 6 extra space dimensions, making it super diluted on the brain. In 1999, Lisa Randall and Raman Sundram had a mind-bending idea. They suggested that there could be a bigger 5th dimension, all curved in a way that we can't even see. And this extra dimension might solve one of the biggest mysteries of the cosmos: dark matter. You know, that invisible stuff that outweighs all the visible stars and galaxies by 6 times? Yeah, it might just be hiding in that mysterious extra dimension.
The average human life expectancy these days is somewhere around 70 years. Hey, your mileage may vary. But with recent advances in science and technology, who's to say future generations won't celebrate centuries instead of mere decades? It does make you wonder, though. What if people managed to become immortal one day? Well, I'd say the funeral homes, undertakers, casket companies, and grave diggers will need to find another line of work. Anyway, before you start picturing yourself in a superhero cape, let's take a moment to analyze what immortal really means. When philosophers chat about immortality, they say people shouldn't necessarily understand living forever. If you upgraded your body and brain to live longer, you'd still be doomed when the universe reaches its best-by date. The universe ending is kind of a big roadblock on the immortality highway. Some have toyed with the idea of outlasting the universe itself, but let's face it, that's really a problem for later. For now, let's talk about age. To stick around indefinitely, we'd need to find a way to hit pause on the aging process. This might sound improbable, But certain creatures in the animal kingdom seem to have cracked the code, like a hydra, a tiny jellyfish-like critter with a knack for staying young. These little guys are mostly made out of stem cells, which divide continuously to form new cells while the old ones fade away. This constant renewal process helps hydras to remain eternally youthful. According to biology experts who unlock the secret of the hydra's eternal youth, the hydra's lack of aging doesn't necessarily mean we can copy their regenerative abilities. After all, we humans are far more complicated creatures. Our bodies consist of cells that do much more than just divide and form new cells. Take our red blood cells, for example, which are responsible for oxygen transport around the body. Okay, now give them back. Our neurons are especially important too, as they transmit information within our brains. Replacing them might be catastrophic for our memories. So it's not a simple case of discarding our old cells like hydras do. The takeaway here is that while hydras may inspire research to help our cells perform better as they age, the idea of biological immortality may just remain a dream. But let's not be too glum. Even if we can't be biologically immortal, there's another form of immortality we can all achieve through our legacy. In a sense, poets can be considered immortal because their influence lives on long after they're gone. There's another creature out there that might teach us a thing or two about survival. Sure, its lifespan may not be longer than 2 years tops, depending on each subspecies, but a tardigrade is one of the most resistant creatures on Earth. It has an incredible trick up its sleeve that helps it survive in extreme conditions for a long time. It's not technically immortal, but it does possess a remarkable adaptation called cryptobiosis. When threatened, it pauses its biological functions, entering a dormant state. During this time, its metabolism slows down to just 0.01% of its normal speed. How slow can you go? But what if technology is our ticket to a prolonged life? If so, nanotechnology might be the answer we're looking for. Imagine teeny tiny machines traveling in our bloodstreams, preventing aging by repairing cellular damage, and even potentially helping get rid of certain conditions. Still, even if we manage to hit the brakes on aging, we're far from invincible. Like hydras, who, despite their eternal youth, still pass away from changes in their environment or predators, we humans are susceptible to accidents and drastic events in our surroundings, like earthquakes or floods. Now, let's talk about artificial intelligence for a bit, too. Futurists predict a tipping point called the singularity, where we'll create AI so smart that it could redesign itself, becoming exponentially smarter until it surpasses human intelligence. The next big thing would be virtual immortality, the idea of digitizing our brains and transferring ourselves to a non-biological form, like a computer. To give us a taste of what's possible, scientists have already mapped the neural connections of a roundworm and used that to program a robot. But let's not get too carried away just yet. The human brain is far more complex, containing a staggering 86 billion neurons compared to the roundworm's 302. So that means we're smarter. Regardless, transferring our minds to computers won't be like living forever in a digital paradise. Others argue that you'd essentially be creating a digital doppelganger, not extending your own consciousness. Even if you think you're ready to sign up for brain duplicates, there's another option we might be able to choose one day. Gradually replacing parts of the brain with chips. Hey, I prefer tortilla chips myself. It might sound cool, but our brains are closely linked to our identities, so swapping them out could have catastrophic repercussions. Immortal or not, we still made a lot of progress as a species. If you were born way back in the 1900s, the odds were stacked against you when it came to reaching your 50th birthday. But today, things have drastically changed. Thanks to remarkable improvements in global health and safety, people in many countries today have the opportunity to live for several more decades beyond that milestone. According to an official report, the substantial increase in average life expectancy during the 20th century is considered one of society's most impressive achievements. The secret behind longevity? Well, several factors. For instance, the management of some conditions has improved, keeping us healthier and less prone to life-threatening events. Back in the 1900s, the goal was to keep people alive long enough to reach adulthood. However, in recent times, we witnessed a remarkable shift. People keep living to older and older ages. It leaves us with questions about just how high the average life expectancy can realistically go, and how long humans could potentially live. Many scientists agree that there is indeed a physical limit to our lifespan, since no one is known to have surpassed 122 years, and even that's highly debated. Regardless, the average life expectancy continues to climb. More and more individuals are surpassing the ages of 80, 90, and even 100. The population of the so-called oldest old is rapidly expanding in comparison to other age groups, and there's no sign of it slowing down. But let's say we figure out all the logistics of immortality. We'd still be in a bit of a pickle. If nobody passed on, our population would explode big time. Every year, we've got hundreds of millions of newborns joining us. It's a continual cycle that keeps the numbers in check. Now, if mortality was taken out of this equation, imagine the flood of infants. This crazy growth would put an enormous strain on our planet. Food, water, energy, and housing, you name it. Everything would be in high demand, and we'd face the monumental task of trying to balance it all out. Now think about this. Knowing that it's all going to end in its somber way fuels our ambitions, sparks our creativity, and pushes us to do great things. We know our time here is limited, and this propels us to make the most of it, to chase our dreams, to make a difference. But imagine if you had all the time in the world. The motivation to do something meaningful could wane as people feel less urgency to contribute or innovate. Our zeal to discover new medicines, explore uncharted territories, or challenge scientific norms might just fizzle out, and we might end up in a world of complacency, hindering human progress. And that's just the tip of the iceberg. Our whole social and economic structures would be shaken up in ways we could never predict. Birth, school, work, retirement, these are the stages we all go through. But in a world of immortality, the relevance of a career might fade, and we might need to overhaul our economic systems and retirement plans. The societal constructs we've always known would need to evolve to accommodate this whole new world of eternal life. Of course, if we were all immortal and didn't age, we could just keep on working, so there's no need to retire, right? Well, eternal life could be a hefty burden. Imagine the weight of endless memories and experiences, watching civilizations rise and fall, and carrying emotional baggage for an eternity. It's not as rosy as it sounds, is it? Not to mention how boring it would all get at some point. So, I think I'll keep my sell-by date, thank you. Ooh, you're on a beautiful planet with unusual nature. Around you are ordinary people walking on this exotic planet. And now, get this, it's our new home. Humanity decided it was time to leave the Earth, and now we live very far away in another galaxy. But what happened to our home planet? Well, our solar system itself had an expiration date. It's been 7.5 billion years since 2020, and the Sun began to expand, absorbing planet after planet – Mercury, Venus, Earth. But the living conditions on Earth were unsuitable for us long before that. Let's go back there. In 4.5 billion years, our entire Milky Way galaxy will experience an incredible incident. The Andromeda Galaxy will hit us at great speed. As a result of the collision, some stars will be thrown into distant space, while others will form new solar systems. But most likely, all life in the new Milkomedia or Milkdromeda galaxy will cease to exist. That's why people decided to pack up their things, get into new generation spacecrafts, and go to distant space in search of a new home. There can be an infinite number of planets in the universe on which humans can theoretically live. One of the main ingredients, the planet must orbit the star in its habitable zone. This means the temperature must allow the water to be liquid. We find similar star systems almost every year and have recently found the nearest one. It's Proxima Centauri. There are at least 2 planets around this red dwarf on which we can build our new home. But the problem is that this system is as far as 4.2 light-years away. So we had to open our garage and choose a vehicle that could take us so far. Saturn V is a rocket that used to take humans to the moon. It could reach the speed 30 times faster than the speed of sound. Today, we have more advanced technologies, like the SpaceX Falcon Heavy rocket. However, its speed is still about the same. It would take such a rocket about 113,000 years to overcome the distance to the closest star. So, you walk through the garage further and see the fastest human-made space object ever, the Parker Solar Probe. Its speed is a little less than 500,000 miles per hour, but it uses the gravity of the sun to accelerate. Let's assume we can build a rocket that can reach this speed. Now, we sit behind a star map, do calculations, draw diagrams, and 6,600 years. And now, let's look at the photon. These are the tiniest particles that travel at the speed of light. And an obvious thought comes to your mind. How do you build a ship that can travel as fast as a photon? Well, until recently, travel at this speed was considered impossible. Fundamental laws of physics say that no object that has a mass can accelerate this much. Energy is required to accelerate mass, and to reach the speed of light, which is about 186,000 miles per second, we need an infinite amount of energy. But it's still too slow. Raise your eyes and look at the sun. It's so close to us, but the light from it reaches our planet in 8 minutes, about the time it takes to go through the drive-thru and get your burger. And the journey to the nearest star will take 4.2 years. You can graduate from college during such a period. But we may have found a way to cheat the laws of physics and travel faster than light. Warp drive. It's a technology that manipulates space and time to break the laws of motion. In science fiction, it's a kind of field that envelops a spacecraft like a bubble or a shell and allows it to significantly exceed the speed of light. And we already have a similar technology, sort of. It's the Alcubierre warp drive. Since it's impossible to move at the speed of light in normal space-time, the ship must move by compressing the space in front of it and expanding it behind it. So not only the ship itself moves, but so does the space-time inside this bubble. In fact, this will allow the spacecraft to move at any speed, even 10 times faster than the speed of light. But to warp space-time, the ship must be simply humongous in size. It will need the quantity of energy comparable to the amount of mass energy of the whole planet of Jupiter. But at recent symposiums, scientists began to say that there is hope. In 2069, NASA plans to launch an Interstellar mission to explore inhabitable planets outside our solar system. We do not yet know the details of this mission. It doesn't even have a name yet, but it will be dedicated to the 100th anniversary of the Apollo mission, the first man landing on the moon's surface. Here, near Pasadena, California, a small group of scientists from NASA's Jet Propulsion Lab are trying their best to make it happen, and their latest calculations have made everyone shout Eureka! It turns out the ring around the ship, which should create the so-called warp field, shouldn't be perfectly round as it was thought before. It's more like donut-shaped. This will greatly simplify the design and construction. And the best part, to test this technology, a spacecraft the size of Voyager 1 probe will suffice. Researchers are now aiming to reach at least 10% of the speed of light and launch the probe to Alpha Centauri. In this case, to overcome the distance of 4.4 light-years, the probe will need about 44 years. For comparison, the Voyager 1 mission was launched on September 5, 1977. In 43 years, it's traveled about 14 billion miles and is the most remote human-made object. It's also the loneliest one in the universe. It has long since left the boundaries of our solar system and is moving further into outer space. But rest assured, scientists have a couple more ideas in their secret laboratories. There are rumors now that they know how to reach the speed of light. The Space Association is considering launching small drones powered by lasers. Nuclear force, as well as collisions of matter and antimatter, can give enough energy to accelerate an object to the speed of light too. But their colleagues in a nearby laboratory are working hard to implement another technology, ion propulsion. It uses gas particles accelerated by the electric field. Simply put, your regular rocket is a daredevil on the road. He pulls the throttle to the max and burns an incredible amount of fuel to accelerate to the speed he needs. But ion propulsion is a careful old lady driving. She slowly presses the gas pedal and accelerates. On the scale of space, the old lady will have more efficiency and will be able to drive much further than the daring young man. Something we'll keep an eye on. Still, an unknown number of years will pass until there's a way to implement warp drive or ion propulsion. We want to make humankind interstellar, but first, we need to keep it alive at least. Now we're actively developing technologies to send the first manned mission to Mars. Colonization of Mars will be the first stage to make our species interstellar. It'll be a kind of rehearsal before colonizing distant planets. We must understand that although the conditions on the exoplanets may be close to earthly ones, we will still have to terraform them. We must test our technology on Mars to warm it up to the normal Earth temperature. We also need to increase atmospheric pressure so that water could exist in a liquid state, and create an ozone layer that will protect us from solar radiation. After that, we'll be able to breathe freely on the surface of Mars without spacesuits. We need to master all these technologies before we can create a real warp drive. Centuries ago, people sailed the oceans and perfected their ships to fully explore our planet. Now, we will be the generation to build new ships and go on long journeys outside the Earth. Warp drive will open up incredible horizons for us. Take a look at our galaxy. There are countless stars. Around each of them may be planets, and on some of them, there may be life. Warp drive will allow us to get in contact with this life and explore our galaxy much faster. And this future is already close. Soon, we'll have the chance to join the pioneers, put on beautiful suits, and travel the expanses of space in search of adventure.